it doesn't. And when it doesn't, you lose all your money. And we should just accept that as the status quo. It's not elitism to ask that the surgeon who operates on you went to medical school. It's not elitism to ask the lawyer who's giving you advice that's going to make a decision whether you go to jail or not actually went to law school and has training. So why is it then elitism to say if I'm designing a complex protocol that's going to be used for years to decades and it's going to be very sophisticated and have lots of attack vectors to it, that the person designing the protocol went to school for that and has expertise in that? There's a small army of scientists working with IO at IO who this is all they do. And that's what they got their PhDs in. They've written 180 plus papers, and we've gone through an academic process where you, as a participant in the ecosystem, know that independent parties have read the papers, looked at the protocols, and have decided that there's merit to them. Not necessarily that they're correct and they're perfect, or at the very least that they are reasonable in their design as a basis for truth. That seems to be a common sense thing to ask and demand, and we do it in every other field of our life. But then suddenly the thing that we would entrust our money, our identity, perhaps our personal safety to, especially with privacy coins or whistleblowing systems, fair disclosure systems of our vote, that we don't have rigor behind that. Why do people say academic waste? Because they cannot replicate what Cardano has achieved. They can't go build an army of scientists. They're not prepared to pay the enormous pain and startup cost of getting those people inspired and interested in writing credible papers. So if you can't compete with it, you have to then say, well, it's not necessary. Yet every single time they don't do this, whether they're designing a new signature scheme to be immune to quantum computers, or they're doing zero knowledge proofs, or they're doing protocol design like a consensus algorithm, they make a mistake. And the problem is it's a moral hazard. The person who pays for that mistake is the user, not the developer who's already cashed out their founder distribution and they walk away into the sunset because they have a perverse financial incentive to ship as quickly as possible, dump, and then walk away. So it's a really sad thing, and I wish more people would be more rigorous. And every time you're rigorous, you get it done. And in computer science land, rigor doesn't really cost you much in terms of competition. It's not like we have to go to a peer-reviewed journal and spend 3 years arguing arcane points with a referee. When you go and publish a paper in computer science, you go to conferences like Crypto and Eurocrypt and CCS. That's how peer review is done with computer science. And it's very fast paced peer review. And by the way, other commercial non crypto projects are doing this. If you look at Google DeepMind, if you look at ChatGPT, there are papers being published by the OpenAI people. There are papers being published by Google. There are papers being published by Microsoft. So that's among the fastest moving industry that we have right now, artificial intelligence. And yet they have chosen to work with academia and to publish their results in peer-reviewed peer-reviewed conferences that are, in this case, AI specialists. So if Microsoft and Google and Facebook and others see the wisdom in pursuing this particular approach, and they're operating on the weeks and months in terms of product cadence, why can't we demand this for protocols that could be in charge of billions to trillions of dollars and going to be used for decades? Would you really want your money system to be catastrophically misdesigned, but you can't fix it? And you just have to live with the flaws for the rest of your life and my life because we didn't take 3 months to write it down carefully and analyze it before we just went and wrote a bunch of code. So, yeah, if they call that academic waste, I guess there's AI waste then, and the entire medical industry is medical waste, and the entire aerospace industry is aerospace waste, and all these other things. It's called adult thinking and common sense thinking. You need checks and balances. You need third party peer review of the things that you do. You need subject matter experts who have expertise and a proven track record to design your protocols so they don't make rookie mistakes. And then ultimately, you need to get into a good cadence where you know how to constantly deliver every few months some update. Good open source projects like Linux and others manage that. Poor open source programs don't. That's an indication of leadership in that case. The biggest issue that I had, and still have when thinking about decentralization is this idea of what is decentralization. It's not really intrinsically clear. You have historical metrics like the HH index that came from things like the Sherman Antitrust Act and this idea of how consolidated is an industry. You have Gini coefficients, which comes from economics. You have the Nakamoto coefficient, which is a novel to our industry. You have things like the amount of projects building on it. You have things like the governance of the repositories for the canonical code and the blueprints, the overall governance of how do you upgrade and update things. There are many different sources of truth for whether something is decentralized or not. So what I do when I don't understand something is I go and found an organization to go and take care of that. So, for example, for decentralization, we went and endowed the University of Edinburgh to create something called the EDI, the Edinburgh Decentralization Index. And now there's a dedicated group of people who work for the university whose day job is to go and think about how decentralized is a cryptocurrency. This has to be either a standards body, a government, or an academic body because it needs to be non commercial. It needs to be objective. And the point of that is that they can begin to use whatever metrics they've come up with to then measure and give a number for a cryptocurrency and say, okay, well, obviously the first one you measure is Bitcoin because that's the oldest and it's considered to be the gold standard and reference point for the industry. So if you can measure Bitcoin, then you at least know what the standard is. And then there's a question of are you better or worse based upon that measurement metric. So we have something called Tau decentralization. It's a paper that's coming out. And throughout the summer, it'll be refined. And actually, the participants in the 1694 workshop will get a sneak peek of it in July when they're there in Scotland. The person who runs the lab is going to present to them. But the goal would be to measure Bitcoin, Ethereum, and Cardano, hopefully by the end of the year. And I would love to see that accomplished by the summit in November. Now, we'll see where the cards fall. And either Cardano will be more or less than Bitcoin or Ethereum in terms of decentralization. I think with 1694, it'll be substantially more and actually will look really good. Now, some people will agree with the methodology that was used by the EDI to establish what level of decentralization there. Other people will disagree. It's okay because the conversation is what matters. Because the point is that they can always create version 2 and version 3, but eventually the goal is for the industry to converge and say, you know what? Version X, whatever that is the gold standard. And we're just going to start using that. And then what happens is that standards bodies, insurance companies, policymakers, regulators can actually look at that. And now suddenly we now have a notion of sufficiently decentralized. For example, in the United States, they say that Bitcoin is not a security. Okay. I guess they're saying because it's sufficiently decentralized, because there's certainly plenty of people who buy Bitcoin with an expectation of return. Pretty obvious. And there seems to be a common enterprise, at least for some people, Blockstream and others, but apparently none of that matters. It's sufficiently decentralized. Doesn't pass the Howey test because of that. Okay, so let's put a number on that. And once we have a number on that, then they have to justify why things that are more decentralized than that number somehow still are securities. It's an interesting concept. At least it opens up a policy consideration. And some regulatory frameworks, like MiCA, for example, could benefit from this and actually put it into policy, as can states like Wyoming, the Middle East, these things. And it's a push forward. So I do believe we will fare quite well once things are measured. And it's a beginning of a great conversation that is not going to be concluded this year. It's a multi-year conversation. And most importantly, it is a North Star for the government of Cardano. The DREPs who are in charge will look at this with their constituencies and they will say, okay, is this good enough? And every time a SIP is proposed, one of the things that an institution can do, like the MBO, is score the SIP against the metrics that we have as North Stars. And the two big ones are going to be throughput and performance and decentralization, and the relationship between these things. So does this impact sustainability of the system, throughput of the system, decentralization of the system, or have nothing to say with it? So then you actually can start thinking logically, like, am I okay with this? For example, is it okay to increase the TPS of the system from 200 to 10,000 if we reduce the amount of decentralization by 50%? Yes, no. What about 20%? What about 5%? These are the debates that people can have. But you notice now you're having a meaningful fact based debate about trade offs of new technology inside the system. So that's the other point of decentralization. There's a policy consideration in terms of regulation, of who to regulate, when to regulate, how to regulate. There's an existential concern about getting rid of middlemen and choke points and gatekeepers who can control your protocol, and you don't necessarily know that. And then finally, there's that question about North Stars of how do we do better year by year? What should be the policy and agenda? Just like HDI is a great steering metric for whether a government is doing a good job or not. Is it improving or regressing based upon policy? In terms of a fourth generation, I've thought about this a lot, and I would say there's probably three pillars that a fourth generation encumbers. One is multi resource consensus. So we wrote a paper called Minotaur, and basically we said, look, proof of work is a resource, hash power. And you can synthetically create that with proof of stake. So stake is a resource, and that's what we do with Cardano. It should not be the case of proof of work versus proof of stake versus proof of X, whether that's storage or space time or history or whatever your favorite consensus algorithm happens to be. What should be the case is what types of resources, if balanced together, would create a proper Web3 platform. We know we need network, computation, and storage. Right now, those are unsubsidized for the most part in a standard cryptocurrency. So why don't we make them part of the consensus mechanism? And so a fourth generation system should have multiple consensus mechanisms, and those are supplied by different people. So you might not have a lot of stake in the system, but maybe you have some computing power or hard drive storage, or you have the ability to relay large amounts of information and be the backbone of the network. Well, why don't we incentivize that and pull these pieces together? And then suddenly you now create a gigantic distributed system that has the ability to replicate what Amazon is doing with their web services or Azure is doing or these other large scale grid hosts. So that is kind of the first step. And what's nice is you kind of accomplish two things at the same time. One, you massively improve the resilience and security of the system because you're not betting the farm on one protocol or one model. If, for example, there's not a really good distribution of the token and a small oligarchy controls 51% of the supply, they can't unilaterally override the ledger and control it perpetually. Similarly, if two or three hashing farms, like with Bitcoin, control majority of the hash rate, they can't override the network. So there's checks and balances in the system. So that's much more graceful. The second thing you achieve is that you get a much more egalitarian system because everybody can contribute something. And if you keep adding more resources, eventually you cover the majority of people. So everybody can contribute instead of a small group of people can contribute as the maintenance class of the system. As a result, you're substantially more decentralized and substantially more resilient. But I'd say there's two other things as well. So the second thing is this concept of zero knowledge proofs and the existence of proof systems and the interplay of proof systems. So you'll see this a lot with zk-EVM. You'll see this a lot with rollups. You'll see this a lot with a lot of these new projects like Espresso or Mina or Cello and what we're doing with Midnight. And basically, the idea is that you basically have this structure where a lot of stuff can go on, and you take all of that stuff off chain, you do some proof magic to it, and then the thing that you're validating on chain, you're verifying on chain is just the proof, not the thing. That's super useful because all that stuff that's going on is not everybody's concern. So here's an example. Let's say you want a poker game. You can do this in a very naive way and write a DApp where the entire game is run by the network. That means every hand is forever known. Every time you want to shuffle, all that randomness, all these things, forever known. And the entire history of the game, all the hands played, all the money that changes hands, the bets you've made, the side comments, all that stuff is forever known, forever. 100 years from now, that poker game you played tomorrow is there on chain. Does that make sense? Because why are we using the blockchain? We're using the blockchain to have a fair payment system, to guarantee that people aren't cheating, to find each other, player matching, and to make sure that we are able to collect our winnings when we've won the game. Okay. Well, everything else You probably don't want to pay to preserve that for a century. So this is where MPC and zero knowledge, these types of cryptographic concepts come into play because you can do all of that in the application domain. And when you're done, you can take whatever minimal thing you need back on chain to guarantee that people are treated fairly and are able to collect their winnings and losses accordingly. There are 1,000 other use cases where you need to do that, like supply chains are another example where you need to verify people aren't cheating, people are carbon neutral or whatever the hell your ESG mandate is for it. But you don't want to reveal that Apple has bought 10,000 of X component or 100,000 of Y component because that could be competitive espionage. They'd be revealing then to Samsung something about their company that maybe they don't want Samsung to know, for example. Okay. So that whole design space of zero knowledge cryptography, rollups, these things, I think is the second pillar of the fourth generation. And the third pillar is identity, figuring out how to bridge identity and get that into in a coherent, meaningful way the whole notion of the movement of money, dApps, DeFi is a very important thing. And by the way, the zero knowledge stuff gives you privacy. So just naive application of identity says Charles Hoskinson, John Smith, Alice did this forever. And it's always known. When you have zero knowledge cryptography, what you can do is prove facts about a person, yes, no questions, but not necessarily reveal who they are. Are they a US citizen? Yes, no. Are they under US jurisdiction? Is this lawful money that's been properly taxed and accounted for? Are they a member of the US military? Are they a politically exposed person? Are they over the age of 21? Are they a accredited investor? Are they a member of group XYZ? That's all you know. It's yes, no. That's what a zero knowledge proof basically can tell you. And you've revealed nothing else about the person other than that stuff. So that whole space of where traditional finance meets DeFi, the real fi, the cream filling in the middle, where you've added identity in, but done it in a way that preserves the liberty and privacy of individuals and remove gatekeepers from that, is the underexplored area. So those three things together, I think, are the next generation, and they make crypto crypto. That's the final frontier because you've achieved maximum decentralization. You've realized the dream of Web3, which is decentralized infrastructure, and you have a resource for that decentralized infrastructure that grows organically with the system over time. You have the ability to accommodate off-chain and on-chain, private network, public network, and you have privacy in the system overall. And then the identity component basically allows you then to add a regulatory layer to products on a case-by-case basis, dApp by dApp basis, not on a protocol level where you're forcing everybody to follow some country's laws. The protocols are independent of that. I'm talking about an application, currency, and a transactional basis, and that can be done by the participants. So, for example, let's say you're building a dApp for security tokens and you want to use this as basically a stock exchange for Burundi. Okay, well, you're going to have some notion of broker dealer and settlement and identity and these types of things. So, it's basically a permission dApp. And maybe they say only Burundian citizens can use this. Okay. Well, that can run in parallel with a completely unregulated product like a DEX, for example, like MinSwap or Sunday Swap or Wing Riders. And that's a really cool thing when you see those two things together that they can run in parallel and they operate this way. And that's the final frontier of cryptocurrencies because you get everything else. With the third generation, you get decentralized governance and interoperability and scalability. With the second generation, you have programmability with the smart contracts. In the first generation, you have this concept of decentralization. So all those things together effectively are a world financial operating system.